It's up to you. We talked about this degrees, you would remember. Nodes having degrees. There are some in degrees and out degrees. And then we talked about some distributions, all right? So how they distribute, like how many, we counted how many, for example, links we have with 6 degrees, how many with 5 degrees, how many with only 1 degrees. And we made a histogram out of it, and we started to think about that. So we will move back to that question, but with a little bit of twist, because there are some more interesting things going on over there, and I want you to please to contribute as well, because I will be asking some questions, and I need your intuition into this, because it is related to well, a very important topic, which is it true that rich gets richer? So that's the question. I mean, it's about money, so very important for all of us. We will try to find if rich gets richer or not. So we have some feelings about it. If you have big money, then people say that you will keep growing in your income. If you're poor, it's less likely. So we will take a look at that. Normally it's normal distribution. When we look around, most of the things are normal distribution. So it's something very usual. For example, when we look at the heights of people, like this one here, they call this living histogram. Living histogram, I think that for some time, people love this idea, and students are getting together and doing this kind of histograms. We always see some kind of a normal distribution. This is what's called the normal distribution. It's all around us. It's about, for example, for our heights, there is an average, so it's so there is no, well, we say that normal. What would be very abnormal is, for example, if we had a, for the case of, for example, internet, this is the picture of internet. This is a very 4,000 pixel by 4,000 pixel image. There are, of course, I don't know how many pages, but there's somebody did count it. Anyway, when we look at the web pages, it is not normally distributed in terms of degrees. You will remember that we already talked about that. We said there is something called the power law. Yeah, I don't know if you remember that. Did you ever heard about power law? Probably you didn't. Did you ever heard about Pareto? This is a guy, Italian, mathematician, and he says, he was the first to say that, you know, well, the income of a country does not distribute with a normal distribution. That's awkward, because everything else is distributed by normal distribution, like our heights, I don't know, size of the stone that you find out there in the street, you look and measure all of them, they are distributed with normal distribution. But this one is not. Like the incomes. At the beginning of 1900s, in an economics conference, he said, when he said that, that was an outrage. They said, wow, how can this happen? Well, anyway, he was right. When you look at the income of a country, it is not normally distributed. And this is what we also feel, right? When you think about the income of the whole world, for example, or how many, you know, look at, like Forbes, for example. Forbes has 100, the top 100 most rich, the richest guys in the planet. So when you look at that, you don't see that it is normally distributed. Or is it? We don't know, do we? I mean, how can we know? Right? If it is like this. So there was a Timothy, you don't know that, but we had a president who was saying middle class. In Turkish it is orta direk. the middle class is the size of the middle class is something like this. Like these are the rich people, more money and less money, right? So is it like this or is it like this? So that is the question. Pareto was saying it is like this. It's not like this. So there are more poor people. When you look at the income distribution, it is like that. So it is also called Pareto distribution. Do we know? Do you have a feeling about this? Which one will be true?
Left one.
Sorry?
Left one, like.
This one, you say. So we have a strong middle class.
I feel.
Or maybe it is something like this. It is also possible. But how about the internet? When you look at the internet, the web pages, you think about web pages, and with the web pages, of course, what you have is that you have one web page. Atakan, I give you the responsibility, okay?
We couldn't
Why?
figure out
Because
how we are zooming it.
How to zoom?
Yeah, because obviously it needs.
It's zooming, it's on the top.
This one?
No. This one. Okay. So instructional. Anyone knows how to operate the camera? We have this in Turkish army that anyone went to the military service yet? No. No, you're lucky. I've been through that. And the military is something like this, In the first day, they get together everyone, and it's all engineers in a room, and the officer comes in, and, as always they do, they like to destroy you in the first, in the first day, they have to destroy you, all your character or your pride. They have to get it away from you, because they have to really train you. You have to be this is just another world, It's the same everywhere. So they goes out and it's usually in the evening, and you get together in a sort of a place which is a casino, like not a casino, but we call it a casino. So it is I don't know how to call it, a rest area. Okay, so in that rest area there's a TV, and the officer comes up, and there's a group of people some of them with PhDs and some engineers, some from different majors from universities, but all of them are from universities. And the officer says, okay, if there anybody from electronics, engineering, hands up. Okay, there are so many. Okay, then how many with master's degree and above? Some of them just a few. Is there anyone with PhD? Maybe one guy. Okay, you're responsible for the turning on and off of this TV set. So that's that kind of a thing. So they go. So they really destroy you. You have a PhD in electronics and responsible for turning on and off only the TV. So what I was saying is, when you think about the internet, with the internet, what do you think that which one is true in terms of number of pages that you are linking? So that means that how many pages that somebody is linking your page? Well, we have our web page, for example, for our blog for this networks and cities, and I assume that nobody is linking our web page. I will be. You do link our web page.
Yeah.
So I have one hit. So think about it in terms of this. You have a web page, and if you receive any links, if anyone linking your web page, your website, okay, in their website, you get one in link. okay? In degree. You got it? So which one is true, do you think, then, for the web, for the whole web? Is this true or is this true? This is the normal distribution, this is the power distribution, or the Pareto distribution. What do you think? What's your intuition about that? Think about all the websites, you know, that which one is the richest website in terms of in degrees? What do you think? Which one is the most famous?
Google.
Website? Google? Yeah, maybe, yeah. Maybe
Facebook.
possible, yeah. Or like CNN or something like that, right? So they would be getting like, I don't know, they must be very rich. Yeah? So, think about it. Which one would be true?
The one on the right, but would be skewed the other way.
You mean this one? Is there another, you say somebody raised hand? Did I see something? Someone trying to say something? No. No, well, that's true. I mean, it turns out that our intuition also says the same, that this is true for the web pages. Like there are so many millions and millions of web pages, like my home, you know, talks about, well, think about the Facebook, or think about Twitter. Think about Twitter, when you think about Twitter and the followers on Twitter, and this is the same thing true. I mean, there are millions of people, just nobody is following, or only their friends are following them, right? Like 5 or 6 or maybe 20. But there are some people with millions and millions of followers. So this is the concept behind the power law. It turns out, in many of the cases, such as the web pages, the Twitter followers, what else could it be? Do you have any ideas what else could it be with power law? I can tell you some. Like popularity. When you think about popularity, that's also like that. And there are many people in the planet, so many, and they just unknown. You know, they're not popular. They're not pop stars or movie stars. They're just ordinary people. And what those ordinary people are doing, they are following these celebrities, and they make them celebrities, of course. So they have a lot of. So it is something like that. Okay. So the idea behind it is this, you know, with the power law, they found out that in many of the cases it is, well, okay, it is something like this. For example, I have k, the number of links, all right, and I have this function. Second power of k divided by 1, but I have the fraction of total number of nodes. So let me tell you. It means if, for example, I have 100,000 links, that means that I'm someone very, very rare. Like that shows that, for example, if I have 1,000 nodes, I am like, if there are 10 million nodes around there, I'm only one. I'm only one person who has 10,000 links. So they found out, the funny thing is that, let me see if I can, yeah, I will do that. When I have this, let's use, they found that this C value is mostly true for the real life examples. Okay, so I'm sorry. Yeah, we are back. So, of course, before going to the, no, let's do it. I mean, on purpose, I didn't put these things on a presentation. You know, my presentations are usually very, with a very few slides. You see that. What I would like to do, I like to do it together with you because, I don't know, that's maybe much better than going over slides and slides and slides so that you can see how I'm doing, you know, how it is being done. No, I cannot see it. Take it off. So for example, I will show you a real life example, okay? If you bear with me. I want to see that if it is really true. For example, I want to look at, I showed you that we had, together with some architects, Nilüfer, Kozikoğlu, and there are some other architects, we looked at the bus network of Istanbul. And I want to see that if the bus network of Istanbul, the transportation network of Istanbul, is following a power law or not. What does it mean? Is that I want to see that if in the bus network I have all the bus stops. All right. I want to see that if some bus stops are very popular and if they are distributed with a power law or not. So this is what I want to find out. So I have here, where is it? Yeah, Nilüfer, IETT, I have this data, I have this. Okay. Here I show you how to look at it. So this is real data. We're doing it on real data, and I will show you some of the things that's available on the web. Oops. It's too big. Okay. So, well, this is my data, all right? So I want to see if it is distributed by a power law in terms of degrees. Okay, let's take, it's the same, like we can take the out degree or the in degree, it doesn't matter. What I will do, I will just copy this bit of information. Into a new sheet. Let's see if this is empty. Into here. I don't need this. I will delete this column. So as you see, I have this. So in order to find out, this is the edge list, of course. And all of them are bus stop names. So I have how many? I have like 39,000 links between bus stops. All right, these are all sorts of links between bus stops. The bus, or well, this one is also including the ferries and the metro. So, okay, but it doesn't matter. That's all right. So what I need to do is to find out how many, how many links a bus stop gets. All right, and to do that, you already know this. I look at pivot table, create this one. So if I want to look at the in degrees, what I have to do, what do you think that I have to do? If I'm going to be looking at the in degrees, there are the source, well, these are the edges, like this. This is the source, target. If I want to look at the in degree, I will take the target. If I want to look at the out degree, I will take the source. Right? Because in, out. So let's say that I'm looking at the in degree. I pull the target here, and it doesn't matter. I pull one of them here, and I take the count. So what it will give me, it will give me the number of target, that is number of edges, doesn't matter, for each target. So that will mean that I will be getting in degrees for all the nodes, for all the bus stops. So when I do this, I have this number, all right? So for easy operations, I copy this, kind of paste over here, and this is the, what is this? Node. And what is this? In degree. Good. So I get rid of this, delete. So one simple operation, I tell you, it's very easy. So you see immediately that, only by looking at this. Can you see this? I'm scrolling down and down and down. So it looks like that it is power law. But do I know exactly it is or not? What kind of a relationship? So what we were usually doing, very fast, very quickly. This is the way that I do. I have to look at the minimum number here and the maximum number. Actually, I know it is 128, but maybe I am. So I want to take some intervals, like intervals of, 10. So this is the minimum number. And on top of the minimum number, I want to add this minus this divided by interval steps. So what it will give me, I have to be reaching 128. Oops. Why it didn't work? I always do that. Why it doesn't work?
Other side.
Yeah, because of the dollar signs. I always forget that one. So I have to put some dollar signs in here. Let's do it here. Right. Okay, I don't. These are irrelevant because they are bigger than 128. Yep. And then what I do, count if, and if this value is smaller than this value, count how many of them are existing in this list. So this count if is giving this to me that we did it before. So if I do this, I know. Maybe some of you are thinking that you're making a mistake. You're making a mistake. I am making a mistake, but that's on purpose. Oh. So I did something wrong. What did I do wrong? Do you know? I know. The dollar signs. Shouldn't forget that. Okay. Oh, I have 228s? I don't. Anyway, it is true because it is in between, there are two between 128 and 115, right? There are two of them, so that's correct. So this is it. So I want to go like this, this is much more fun. in my opinion. I don't know how about to listen like this. I mean, you know, compare it with the PowerPoint presentation. I mean, this is, in my opinion, this is better that we do it together. So what next we're going to be doing? This is the histogram, and let's draw that and see it. Yeah, the bar chart is okay. So it is something like this. All right. So when you see this kind of a power law histogram of this sort, what you normally tend to like to do is to, for example, when you have this here, normally you would like to do automatically, I don't know, this is my intuition, is to get log of both sides. So it will become crowded in here. So when you have this, you will have right? So this is like, you know, if it is y, this is similar to, let's call this a plus c times x.
Minus
Was it minus? Oh yeah, you're right. Yes. Very good. So it is minus. So what is this? This is a line. Okay, so it will turn out to be a line. So what I would like to see, if I will be able to get a line, you know, by getting the logs, taking logs on both sides, because it's going to be, you know, it's more easy to visualize it. With this, maybe it is not. So let's see what's going to happen. Let's, instead of this, let's get rid of this. So what I will do, this is my first value. I will take the log. No, let me do it this way, because I'm curious. I don't want to do it this way. So I got the log of this. All right, so this is how it looks like. So, but this is one value that I have. Let's go step by step. If I draw this, wow, it looks like a straight line, isn't it? More or less. But no, wait. There is something that I'm missing, okay, isn't it? I need to get log of this as well, correct? So, excuse me. Oh, no, I don't want to do that. I want to take this, and I want to do an XY plot, and come to data series, and X values are located here. So it does, I mean, when you look at it, yeah, I have a bump here, but that's okay. Nobody is perfect. We have a song for that for all the rest of the team. I recommend Orhan Gencebay. Yes, the translation is Nobody is Perfect. The name of the song, I mean, it's great. Good song. And it is correct. Nobody is perfect. So look, there's a bump. So who cares? I mean, it is straight, isn't it? So, well, this is how you do it with Excel. But the nice thing is that you don't have to do it all this thing. I just did it for you, just to show it to you how it's being done. But you can do is, oh, somebody sent me this. Somebody sent me a video.
Yes.
Who was that? You did. Okay.
The middle grids become least important, and other ways are same equal and the most important.
So you proved that it is possible. You remember that we talked about, okay, what is the next video? We talked about that there was this between the centrality and when we look at the between the centrality, this link was with the highest between the centrality. So it was what between the centrality is when you take all the shortest path travels within a network. You look at which one is the highest, and this one is the highest. You know, most of the people are passing through this. And the question was, can we make it less interesting, less important? Like the bridge, the Bosphorus Bridge is very important. Can we make it less important by making some other roads more, or making the bridge, for example, so wide, so many lanes, is becoming less important, but some other roads in the corner of some town, some small village in Istanbul, very important because it's so narrow. And you say it is possible.
Yes.
Yeah, you did it.
Yeah.
Yeah,
In this relation, yes.
he did it, yes. Exactly. So this was it. So
You reduced the amount of traffic flowing through that bridge by doing what?
No, he increased the traffic, the capacity of the bridge he increased, right? So
No,
it is becoming less
actually,
important.
I'm not increasing the capacity of bridges. I'm closing some roads,
Oh, you're making them more important.
more important.
So it is the same thing. I mean,
Yes.
you would have increased the capacity of the bridge. So look, the bridge, as it stands, is very important because when it disappears, it's, I don't know, it's important. Anyway, there's more traffic over there. We know that. There's more traffic on the bridge. So what happens that if you increase the number of lanes, like make 100 lanes of bridge, you know, a big bridge, and make some of the other, I don't know, this street, Nispetiye Street, for example, very narrow. So it will become more important. And the bridge will be less important because of the number of lanes over there. Yeah? So that was the idea, and that was the question at that time. Would it be possible to do this? Is it clear or is it? It was, you know, several weeks ago. No. Is it clear or not? No, it is not clear. I can understand. I read your mind.
Yeah, of course it's not clear. Because, you know, usually when you increase capacity on roads, the multiplier effect means that it actually increases the demand and use of that road. So by creating...
Okay, I understand. That's another factor that we are not taking into account.
Yeah.
Yeah, that's of course, you're right. We're looking at the real world. We're only getting a model of the real world and working on that model.
Because it changes driver behavior. They go,
Oh yeah. I agree with you. Yes, if you invest more in a city, there will be more people coming into that city, for example. But I don't know, it's not something like, oh, they built a 100-lane bridge in Istanbul, let's move there. But it is like, I know, there are some effects happening that people start to move to Istanbul. Oh, there's more investment going on there. Because why? When you make the 100-lane bridge, of course, there will be more jobs created. It's very difficult to make a 100-lane bridge over Bosphorus. So there will be more people coming in, there will be more grocery shops and everything else. So people wanted to come to Istanbul. And suddenly it's going to be again crowded. And you will think, oh, we made a 100-lane bridge and it is still congested? How is this possible? Yeah, in the first place, it is a positive feedback mechanism, right? So that's what you mean. That's all right. I mean, that's true. But no, this was like a hypothetical. We were only talking about the model in the model's framework. Is that clear? If we stay like that?
So by reducing the lanes on a less significant road, you actually decrease the between the centrality of the more significant road.
Yeah, we say that, look, normally the between centrality doesn't count weights, right? Between centrality is just between centrality. When you look at the definition, it doesn't say anything about the weights of the edges. So,
It's just
But-
the passing.
but we can make up something with between the centrality and the weight. Like it could be a capacity, it could be, I don't know, another thing, like number of flights per week between the cities. We can add that up, and we can come with a different number, and we can tell this number is our new importance number between the two nodes. A link. For a link, this is our importance number. That is some function using between the centrality number and the weight number that we have, like the number of buses on that line, or number of lanes, or the width of the road, or it could be the number of flights per week between two cities. I use that number, multiply it with a factor, plus between the centrality. It could be something like that. I end up with an importance coefficient. So that is the idea. So the question was, would it be possible to change that number, to change that number by changing the weights? Shall I? I don't know. Who opened up this subject, by the way? Was it me or? I say, look, if this is between us.
You were going through the slides, and then you just said, "Oh, someone sent me the video."
It was my fault. You're saying that it's my fault?
Yeah, I mean.
Now you're saying that it's my fault?
Yeah.
You shouldn't have said that. I mean, why you are?
You're leading the class.
This is the importance number. Okay, let's call it, or no, let's call it importance number, if I may. And I am my betweenness centrality. And I say, let's say that there's also weight. So, and there are some factors here, like, I don't know. Give me maybe some, yeah, why not? I mean, we always use these. There are some Japanese, okay? So we have K times B, and this is K times W. So I have I. So it's obvious actually that this is, if I take only B, some of the things in the network, like this one is highest, right? Like this one has the highest B number. It is like this. And this one is so tiny, it is like this, okay? This is the B number that I have. So what I'm saying is, if I can change it by changing this W, can I change this I, and to make it this one, this is I now, this is B, this is I. Can I make this I tiny, and can I make this I so big? Now I can, because it showed that he made a whole big simulation out of it, right, Emrecan?
Yeah, it's possible.
It's possible. Out of experience, that it is possible that I can play with these numbers. Change, I'm allowed to change the W's, I'm allowed to change the key and the cup, and so I can. So that was about it. Do you remember this homework?
Yes.
Emrecan does, but anybody else? Really?
I remember.
You
I
don't
tried, but
remember?
I couldn't.
You couldn't remember, okay. So that was this homework, anyway, but he did it. Anyone else did it? No. I know. Okay, so what I was saying, yeah. So I said we did it, but okay. How are we on time? Are we still recording?
No.
Why are you not telling me?
Direkt
It stopped?
direkt işte.
Yo, bitti ama ben tekrar başlattım.
Okay, that's good.
Ha.
Oh, that's
I'm the
fine.
cameraman.
Yeah, okay. And the camera, we were a little bit suspicious about your, you know, because you were trying to find where the zoom is and, and what is this?
The camera automatically
Shuts us
starts
up.
a new video every 10 minutes.
No, it's at like every 29 minutes and 50 seconds. So it has to restart. Do we need a break?
Yes.
Yes, somebody needs a break. Okay, let's do a break. Then I will show you something else. Okay, break, quick. The answer is, I don't know. Well, the longer answer is, we were just talking about that one. Actually, but I will take a look at it. When do you want the answers? I'll give it to you that time. Like next week is okay?
How many weeks do we have left? 3?
Just 1 week.
2 weeks more. No?
Just 1 week.
1 week? Only 1 week?
Yes.
Okay, now I have to go back and no, 2 weeks? You were saying 1 week? Okay.
We have final observation.
Okay, how about sometime on Wednesday?
The finals on the 4th.
Within this week, you know, within next week, I will give you, I will grade you, okay? Within next week? Good? You look very cold. Yeah, cold. Yeah. So, is it all right? No, I was saying that I was more interested with the answers to the Go question. You weren't here at that time. That we asked about a question about Go. If you look at the website, you can see some the game of Go. Do you know?
Oh, yeah.
Go, yeah.
Yeah, the game of
So
Go.
how would you create a network?
Yeah, and I was telling them be adventurous about it because there's no right or wrong answer about that. So when I say adventurous, you know, when I say dress adventurously, like you wouldn't go and dress like a tie and a suit, you know, that you would be creative and stuff. So I immediately look into the you know, well, all the other stuff. I don't know. Maybe it is very fun going into the exam. You know, taking an exam. I mean, maybe it is fun for you, but reading and grading it is not fun. You know, that we really don't like it too much. But what I would really like is the answers that you were giving to the Game of Go question, because this is not something with a right or wrong answer. This is, you know, something that you will be creative about. Come up with an idea that really that we can use. Because this is an open question for us, and the question is that can we predict the next move of the opponent? That's the question. I mean, that we are looking for. And that's the way that, you know, the network has to be created, keeping that in mind. And this is a very important question. Not only for Game of Go, because we're using it as a toy, it has other applications in other fields, if you can predict the opponent's next move. All right, so coming back to Cytoscape, everything that I showed you about this power law and everything, you can do it with Cytoscape. So it is easier. I show you how to do this, and it is better because it gives you, it fits a line. Because we can do this in Excel. We can really go to the Excel sheet and try to fit a line. Because we can find 2 points, and from 2 points we can have a line. We can make a regression out of that, the whole points, and we can fit a line, right? So this is the whole picture. Anyway, looks like that. This is Istanbul, by the way. You're looking at Istanbul. And what you do, you go to plugins, change something to make it more familiar to you. And you say, okay, analyze network. I will treat it as undirected. It will take a little bit of time. Yeah. This is, you know, how many nodes are there? It takes some time. So you may say that, you know, instead of waiting for such a long time, I can go and entertain myself with Excel and do it over there, because at the same time I'm thinking and but I don't know, this is an awkward moment for me that, you know, I pressed run and I'm waiting for me to finish and I have to fill in the blank, like say something to you, that you're staring at me and this
Well,
is
let's talk about what some people came up with regard to the game of Go.
Oh, nothing came out.
No one.
Nothing interesting came out yet.
Okay.
If you are, well, you're free to resubmit something.
What do
If
you want?
can- What do I want?
No. What do you want us to do, or can you maybe give us?
Say it again? Maybe I can
Maybe
ask you again.
demonstrate an example for us instead.
I don't want to give an example to, you know, direct you into some mode of thinking. I want you to be really free about, you know, I'm looking for your creativity, so I don't want to ruin it. I have some ideas, but the idea, what we want to know, the goal is, as I said, we want to understand what the next move of the opponent will be. That, you know, that after 100 moves, at the beginning you cannot know that what the person will be playing, where the person will be playing at. But let's say after 20 moves, 30 moves, 100 moves, where will be the next move? We want to know, we would like to know that. So what it depends, of course, is the forces, the influences, because all of the stones are radiating some force, and there's an opponent force as well. So those forces determine sort of where to play, and I want to be able to map that force field. I also included one video showing some colors. Maybe
Yeah.
did you see it?
Mhm.
That was on the website. You know, as people are playing, black and white is playing, the colors are changing. There's a color change with every move. So think about it, that there's a force field. So that's how it's.
Like the probability of the opponent's move being somewhere.
Yeah,
there
I
is
mean, I
increasing.
don't really want to know exactly where, but whereabouts is enough for me, for the time being. Whereabouts is more important. So I want to be able to know that with the network that you're going to create. So it is not like a, I don't want the grid, you know, so most of the people make this grid. Grid is not important for me. This is not what I'm looking for. The grid is not really interesting. Yeah, I know that there is a grid. Just get rid of the grid and think about only the black and white stones. That makes sense? Because yeah, there is a grid underneath, but this is so boring, you know, the grid is boring. We have to make it a little more abstract in order to get to some point, somewhere. So, oh, we're halfway through. Okay. I move on to the next subject now. The next subject, well, at the end of this, it is going to be like, I will show it to you, and it is going to be, well, okay, so what? I mean, this is going to be only a line, you will see. So I promise, there will be a line, and this works. But the nice thing is that it also gives this A and C value. So this line, you know. So you will get an understanding of what is the slope of the line, and what is this A value, the offset. And the thing here, what's interesting for people, what all the research is about. Oh, is it going to be 2? This value, is it going to be 2 or something close to 2 or not? So there are people are interested in that. So let's move quickly to the next subject. This is gonna, in the background, report. But the next subject is very interesting. Why I told you all these things all along? Okay, what's this all about? I mean, why we are talking about this in the first place? Well, we're talking about it because the next question is interesting. But in order to understand, for example, if you were to run the history, if you were to be able to go back to the history and rerun it, would some of the things be popular again? Like, would Harry Potter will be popular again? Will be selling that much? Was it pure luck? Is it so? Or would it be repeatedly getting, or would it, for example, would somebody famous or rich, let's say somebody famous, somebody rich, would that person be rich again if we rerun the history? If we go to the popularity, popularity is something like, do you always feel like if you go to the, I don't know, I think there is a website called Spotify, right? And there are others, what else? There are others as well, right? Something like that. If you go there and listen, what happens is that you tend to choose the ones who are popular, trendy. And you look at Twitter, you look at YouTube, things quickly, like the, what was that, Gangnam Style? Gangnam Style. What's that? I mean, would that be popular again?
They call it.
If you rerun the history, was it pure luck? It was only because some people clicked on it and some people more clicked on it just out of curiosity. There are some websites, there are some videos like that, It is like a very catchy, nice lady at the start, and the rest is just nothing. Or is this like, the most scary video you would ever see? There's nothing in it. It is just, you stare at a blank screen and at some point somebody says, Bob. And that's all. But everybody takes a look at it because everybody else had been curious about that. But there's nothing in it. So how do we understand? How can we get the bottom of this? One way to understand is first, do we have an answer for that? We can all talk about it until the morning that everybody has an opinion about if Gangnam Style will be famous again or not, right? But we have to really talk more intelligently, I would say, or more intellectually. How can we do this? In order to do this, we have to understand the mechanism. How this is happening. Can we replicate it? Can we do it with an algorithm? So that's what we have to do now. And really, this is what the research going on as well in this subject. How can we create power law? Where's my power law? You see, here's my power law. Can I replicate this power law in a network? What was the question?
Well, it was kind of sidetracking a bit because I was going to mention that there's a book written by Malcolm Gladwell called Outliers, and he talks about, for example, he uses an example of a successful athlete, like let's say in the NFL.
You mean the 10,000 hours?
Yeah, and also based on the person's date of birth, although they may join the team at the same age, where they were in that year when they were born changes the effect of their opportunities throughout their sporting career or any of those things. So
let me talk about this, and you think about if that makes sense. Well, if this makes sense, or if really what you said or Malcolm Gladwell says in line with what we're going to find out. First of all, here it is. Node degree distribution. No, sorry. So we have this fit power law. So it gives you A and B, and it draws a line. looks like it, well, not very much like we had hoped for, but that's understandable. Well, most of the people, well, since you know why this is here in this network analysis plugin, they put this, I mean, because everybody is looking at power laws. If there's a power law applicable for this, for degree distribution in a network, you know, you will be seeing that a lot of the times. But let's come back to the more important question. This was just to show you how you do it in Cytograph. It's very easy. You go to the network analysis, and the next thing is that you look at the node degree distribution, and there is the fit a power law button over there, and you click on it, and that's it. Simple. Or you do it on Excel. It's more fun. I don't know what your definition of fun is, but you will probably be asking me. So the important question, let's go back to the important question. The important question is that how are we going to be creating a network and make sure that the degree distribution is a power law? Can you give me an algorithm? Let's assume that I have 100 nodes. 100 nodes. And there are no edges. I want you to create edges between those 100 nodes to make sure that the degree distribution is going to be a power law. Think about that. Or let's do it more, because intuitively it will be much better. Let's think about this class. There are how many people? 6, 10, including me, 14. There are 14 nodes. How can we make sure that we are, you know, randomly, you know, there's no meaning, no, just going to be random. Not random, but with a following an algorithm. I want you to write me an algorithm which will create a degree distribution which is a power law. What could it be? Let's think through. I mean, if I create links randomly in between all of us, would they create a power law?
No.
No, no way. I have to narrow it down to,
We'll make it true.
you make a tree,
Yeah, you make it true, and then you'll get it.
but how am I going to making a tree? You have to tell me how to make a tree as well. I want some simple steps. Like take this node and take randomly another node and link them. That's one algorithm, but that is randomness. So we intuitively know that it's not going to create a power law. Let's try. Let's try. You know that how many things you can do with Excel? Unbelievable. So I said 100 nodes. Let's label them like 1, 2, 3. Is it okay? I think that's all right. I mean, I think that's fair enough. If it is okay that if I make it only 50, because I'm already get bored. So what I say is, if I do this randomly, so this is the source target, okay? This is the, what I say, this is the source node and this is the target node, okay? So what does it mean if I do it randomly? Oh, is there a random function here? I know that there is, but you know, it's all I'm trying to. Let's look at the randomness functions. Okay, there is rand, returns a random number between 0 and 1. Okay, well, this is useful. But this is another one. Returns a random integer between the numbers you specify. That's better. I choose this one. The top one is 1. The bottom one is No, the opposite. Anyway. Okay, so, all right. Okay, good. So this is what I got. Will that create any power law? What do you think? I don't really need to look it up. I mean, I don't want to do the histogram. Even that you all agree about that this is not going to create a power law. But what would do really help me to ensure that I will get a power law? What can I do? It's even that simple, you know. I can really do this here on the Excel sheet.
Automatically eliminate a couple from the random connections. You just have to make a few of them. You just have to make a few of them outliers, and you'll automatically create a skewed graph.
And which ones I'm going to be eliminating?
The majority. To make the minority highly connected.
Yeah, but which one is going to be minority? How I'm going to decide which one is minority, which one is majority?
Well, the majority will be highly connected. Sorry, the minority will be highly connected.
So what you say is that you select randomly some of them.
Yeah.
Let's say, but in that case, this is not something that I want. I don't want to choose, or I don't want to really say that many number will be highly connected. I want it to be emerging. In your example, this is given. Like you say, I'm selecting two of them to be highly connected. You're giving it.
You're saying what can you do to the conditions?
Yeah, and then this is going to be emerging.
Just as a result of the conditions, not as a result of your action.
Yeah, it's going to emerge. There is, let me, because running out of time, you know, and we have only 1 week left, you said? Somebody said that? You sure about that? Okay. So I have to be a little quick. So the way to do this is this. If I do something like this, think about it. Let's do it like this. If I, for example, say Atakan, or no, somebody easier, Hayato, could you come up here? Yeah. If we say something like, you know, if we get a game, that at the beginning I select randomly two people, and he is selecting me as the link. And if I say to everyone else, step by step, one by one, stand up and choose only the people that are standing. Don't choose anybody sitting, but choose only the people who are standing up. And one by one, you step up. You got it?
Yes.
So what would happen? Thank you very much.
Yeah.
Would that really help?
So yeah, you're doing conditions to say, okay, you can only choose between these
Yeah.
when making your connection.
Yeah, like for example, I can do this over here. This is one, and I say this is Hayato. 2. Okay? So the next thing is, give me a number between 1 and how much?
2.
Yeah. So I'm selecting him and he's selecting me in that case, right? So how I'm gonna do that? I will say row number -1 is necessary, believe me. Okay? So the question is this? Now, is this okay or not? Did we get it? I mean, are we sure that this is power law? Let's see if it is. I'm not so sure. So I do I don't care if it is, you know. Yeah, pretty much. Not too bad. Okay, now the next question is, can you make this better? Increase this effect. What we did is that there's a random number between 1 and 5. 1 and, 5. No, not 5 itself, but 1 and 4. We don't want somebody to link to itself, no reflexivity. Can we make this even better? So, well, this is the question that people are really thinking about these days. Not that simple. Can we make it even better? There's a way to make it better. Yes.
Only choose B columns, B randomly yeniden seçeriz.
I will add the subtitles. You say it in Turkish.
O B'dekiler random seçildi ya. Orada B'de olanlardan sadece B'dekileri tekrar randomly atayacak bir şey yapsak. Şimdi B'dekiler ayağa kalktı. İkinci turda sadece ayaktakilerden yine seçebilsek, bu sefer ayaktakilerden daha fazla link olacak. Bu da power daha kötü.
Türkçesini anlamadığım için çeviremiyorum. What I said is that I didn't understand the Turkish version, so I'm not able to translate it to you. So that was my goal. But anyway, you say something like people are standing up, step by step.
Some people
Stand up, okay, and then there shall be a second round. And with the second round,
we have to choose only stand up randomly, not 1 to 50, only such as 1, 4, 5, 6, only 4 of them, and we have to choose one of them.
Yeah, but would that create a bias?
After that, some 4 is have more link. After şeyden sonra işte bir daha seçtiğimizde bazıları daha da çok alacak. Yani giderek azalacak.
Oh, you say something like, okay, could anyone change this algorithm a little bit to work, or make me understand it? Like it could be something like we pass through the first phase.
Tahtada gösterelim. Çok kısa bir şey. Bence bu hani sitelerde de popüler videolar öne çıkıyor. Orada mesela onun yüzünden bence daha çok.
Okay, he says that this is actually how the popularity of the YouTube videos are working. So he has a formula. Maybe we can get rich out of that.
First 1 and 50 biz random seçiyorduk. Daha sonra bunlardan bazı şeyler geldi ama hepsi buraya gelmek zorunda değil mi? Bunlardan bazıları buraya çıkmamış olabilir. Sonuçta random seçtik, tamam mı?
Oh, okay.
Biz bunu çıkararak mı yaptık?
No. Well, okay, this is how it works. You know, with this one, how it works, I pick up everyone that are, you know, I pick up randomly from the ones who are sitting to pick up somebody who are standing up, you know, who are, look, at the beginning we are only 2. I link you, you link me. And everybody else is coming up. And I choose them randomly. And randomly I choose one person, or it could be, you know, 1 by 1. Over here it is like 1 by 1. Like this is the A column. People are sitting, are A column. I'm number 1, you're number 2. Or make it, okay, you're number 1. All right. You're number 1, I'm number 2. And we select each other. And what happens over there is that 1 by 1, starting from him. What is your name? Murat. Starting from Murat, and followed by Atakan and go on. They are randomly choosing one of us who are standing up. But his suggestion is interesting because he's saying that let's make another round. You're saying that let's make another round. This time everybody is standing up. And let's say that, let's go on and make, something like let's choose 2 people and let them sit down and let's reverse the whole process. And the ones who are standing up will be choosing some people from the group of people who are sitting down. You got it? One, and maybe one of these people. 1 and 2, for example. I can immediately say that it's most possibly that the first 2 people who were standing up will be getting more links, right? Because everybody else will be selecting them, even though they are selecting randomly. The chances that because they had been there earlier, like in popularities, the video popularities, or that somebody is getting famous, was there already. Like Malcolm Gladwell says, that the 10,000, that's what you meant. You see that there is
so you just keep on having.
Yeah, there is a correlation with what he says and what this is, how we're explaining it. And we can reverse it. I can again say that number 1 and number 2 now will sit down, and everybody else will continue to do that. So make it one more time.
So if you keep
That
having
means
more
make
rounds,
it one more time.
if you keep having more rounds,
Yeah.
and you keep on increasing the connection to
Yeah,
whoever was
maybe
there earliest.
We have to try that. I mean, you can try it. You saw it how I did it in Excel. You can do this. But there is another way to do this. Let's suppose I will show it to you. This is not. I'm so used to looking at my emails. I cannot stop myself. I show it to you so you also know where to read about that on your book. So we're all the way down to chapter 18. You see? Okay, here it is. That is the algorithm. And that one says, like 50-50 chance that it says about pages. It is like nodes, pages are nodes. We are creating pages in here. We are creating nodes. Nodes are created step by step. When page J is created, it produces a link to an earlier web page according to the following probabilistic rule. Like we can say P is 50, like 50%. 50% probability, page J chooses a page I uniformly at random from all earlier pages and creates a link to this page I. That is what we did, right? This is what we did, exactly what we did. But
You
now,
gave them 2 options, 50-50.
no, yeah. I mean, the first part, forget about the 50% probability, the first 3 words. The rest is what we did. But it adds another thing. It says, but 50% probability, there is another rule. We did this first part in our example, but he adds another part. I mean, they add, these 2 people who are writing this. They say, with probability 1 minus p, that is, they say 50% again, half of the times, page J instead chooses a page I uniformly at random from among all earlier pages and creates a link to the page that I points to. What does it mean? Can somebody explain it to me? What did I say? What was that? So the first part was exactly what we did. What is the second part? Oh my God, what does it say?
It automatically picks up the friends of its first connection. So every time it creates the first connection, and every time its first connection makes another connection, it also creates the third connection.
Does it make sense?
There's like one connection, and then he makes the second, and automatically creates the third.
Is it clear? No. No, you have been really tired today. Like trying to fight yourself to stay awake. It looks like. Anyway, so I'm not really not asking you if you understand it, but somebody else did understand it. Besides Atakan, you got it, Timothy? Really?
Yes.
Okay, good. You're proud. I can see that. How about you?
Not so clear.
You got it?
No, not so.
No, okay, no. You didn't got it. Okay. Look, what it says, page J instead chooses a page I uniformly at random from all earlier pages. Can I draw it? Maybe I can visualize it. If I can visualize it, is it better? What do you think? Can we do this? Can we visualize? So the first thing is there are some nodes here. You see, this is a group of nodes. This means. So I create a new node in the first part, and it is linking one of them randomly. Okay. So now let's see what the second part is doing. Instead of this, it says I'm creating this new one. And it says, instead chooses a page I uniformly at random from all earlier pages, okay, one of them, like this one for example. And creates a link to the page that I points to. Okay, this is I, okay. I choose this randomly, right? And of course this has a link, right? Within this group. Within this group, it is linking to somewhere, like this one. Let's call it K. So what I'm now doing is, this is me. This is me. What is my name? My name is my name is Jay. My name is Jay. And what I do is that I choose again, like previously. I'm choosing this I, randomly picking it up, but instead of directly linking to it, I ask him to whom you are connected to. Who did you choose? And this guy says, I chose K. Then I link to K instead of I. Is it now clear? So would that create more, is it better? What would this create? What kind of an effect? Would that make a stronger bias? Let's try. Okay. I put another one, so anyone, I don't know. At some point this is going to be happening. Okay, and maybe this. So now I'm adding this, and I'm randomly choosing, I don't know, this one for example, and or this one. Okay, let's do this. Now I'm doing 2B. Now this is my new guy, and this new guy will be choosing one of them. And let's say that it chose this one, but it has so many things. I can set up that it will choose one of them randomly. Would that really create some stronger bias?
No, I don't think so. I think it's the same. It's our old example. With you and Hayato doing some friends.
What would happen if I change the probability? You know, this is something that interests me. I mean, it talks about the P, right, over here. It talks about the P. if I change the P, what would happen? It is definitely going to affect. I mean, in my opinion, what you say is that it will have no effect, no change. Is this what you say?
I say that in our first case, for example, you and Hato are picking the one from classroom,
Yeah.
and he picks the choice of the pickle ones. But yeah, how can I explain? I don't know, but you pick someone, and he picks someone from your initial group.
Yeah.
This case, I think, is the same as you did in the table.
I think I should.
In our first case,
I should be adding. I'm trying to simulate, try to understand. I can do this. I mean, what needs to be done actually is to write an algorithm, put it on Excel, and run it. We can do that too. But let's try to do this like this. When I have somebody new coming in, so randomly we'll choose somebody. And if I have this one coming in, and if I apply the number 2b, the second case, not directly choosing one, but we'll be choosing, well, we're looking at the transitive relationship, I would say. So, out of this tree, if I choose this, for example, I will be choosing automatically, because of the description, I have to be choosing this. Right? Look, this is what I'm doing. This is the group that I have, and I constructed it using A. Okay? So I'm adding the fourth node, okay? And now I'm using B. Let's use B. What B says, randomly out of this group, choose one, but don't link to that one, but instead link to the one that it is linking to. So there are three cases, okay? Let's do all three cases. Okay, if I choose this out of this tree, what will happen? I have to choose this, right? If I choose this instead, I have to choose this, right? And if I choose this,
And where does the probability get involved in this?
the P, you mean the P? Don't think about this P now. At least, I'm not talking about the P. I said, I'm taking an example, without this, don't think about 1, 2, 3. This was my number 1 node, this was 2, this was 3, and this was 4. I constructed this number 3 using A, rule A, okay? But with this 4, I'm choosing to use B. That's my choice. It happens that it is number B, it's B now. So if I look at this, for all these cases, let's see what happens. So how many in degrees I have? I have 3, 1, 0, 0. I have 2, 2, 0, 0. I have. Now, can you see that there is a stronger bias? There will be a stronger bias towards the one who has more links with this rule B, right?
Yeah.
Can the camera still see me? I'm going to be famous after this. Do you think that this will be viral in YouTube? I don't think so. Anyway. But I think, yes, last week's video will be very famous because of the subtitles, maybe. You got that? That's interesting. This is nice. I mean, I find it very, very nice. So if you change the P, it will be, you know, it will have some effect. Of course, but we have to look at it. I mean, what now I am curious about is to write this, just like in the Excel that we did. But it's not that simple, you know, that you can understand it, it's not simple. I cannot write it just as it is, that I wrote the first rule. The second rule is a little more tricky. Do you think I can write it? Maybe I can. Do somebody have an idea that how to do this? Okay, this is going to be 2, this is going to be 1. Okay? This is fixed. So what I want is...
That works if the direction of the link is 1, but if you end up creating the direction changes,
this number here, then randomly, what was the rand between, was it? What was the rand between, okay. I forgot to. Okay, rand between 1 and row minus 1. But if now I'm making the B case. For the B case, it works like that. I first choose it's exactly what I'm doing with the A, but instead of linking to that, I'm looking at that number. So this is really advanced spreadsheet usage. So what I need to do is this. Okay, I'm in this case, for example, I'm looking at randomly one of them. You know, in the first case, this is A. But what happens if for the second case, the B case? For the B case, I have to choose one of them. Like, let's say I'm at row 6. Okay, I'm choosing one of them. I'm choosing 4, for example. And I'm looking at what 4 is pointing to. It's pointing to 1. Yeah? So I get this 1. Okay, so this is what I need to do. So I will choose something in random. Okay? This is, I don't know if it makes sense. So in the first one, it's easier like that. I am, for example, number 8. I'm now doing it for number 8, okay? In the first A case, I'm only picking up randomly something between 1 and 7. That's it. And I put that number over here. But now for the second case, for B, what I'm going to do is I will pick again a number between 1 and 7, including 7 and including 1. Let's say 5. But instead of writing 5, I will take 3 from there. Because 3 is written in 5. So because that is what 5 choose. This is what 5 chose before. That it chose 5, it chose 3. So I'm going to be doing this instead of directly looking for I. So how can I do this? There's a way to do it, and it is called address. And you have to give the row. This is the row, and you have to give the column. And the column is 1, 2, 3. Okay, but this is only going to be giving me the address. So there's another command. It is called indirect. It takes an address and executes it. What does it mean? We made a mistake. Let's try to find it out. Okay, if this is bigger than E, so I said false. No, I don't. What do you mean by false? Because of the parentheses. Look, there has to be a parenthesis here. Okay, this is correct, this is correct, this is correct, this is correct, and this is too much. Yeah, now it works. So, I have to put a dollar sign here. Okay. So now let's see, what is this error? No, it shouldn't be this. There are no mistakes anymore. So the question is that is it more biased or not? So the time is up, I guess. This is already, there's some people left. I don't want to go on too much, but this is ready. I mean, we did it. That's it. All you have to do, let me upload it to the website. You download it and you take a look yourself. Change this number from 0 to 1 and see what will be the effect. And what you need to do is get this C column and make a histogram out of it. Each time, like you can say 0.2, 0.4, 6, you can change it like that and see how it works. There is a claim in the book. It says something, what happens when this probability is changing. Okay, so see that if really is true. You got it? Is it fair enough? I think it is interesting. I mean, we did it. I mean, it's a little bit complicated formula, it looks like, but it works. Promise. Promise this is working. It really works. You can take a look at this address and indirect commands, what they mean. And I tell you what, now you can stop.